So in special operations, you have parentheses, brackets, exponents, square roots, nth roots, factorials, which we use in statistics. And then we have the calculus series where you have integrals, double integrals, triple integrals, linear integrals. So, I mean, there are over 400 operations we can use in mathematics. Then once you do that, you have multiplication and division. And then finally, we have addition and subtraction. Notice the second and third, multiplication, division, addition, subtraction, they are on the same level of importance. So division doesn't supersede multiplication and vice versa. So whenever you get to an equation, it's as you read it. Mathematics is a language. When you read mathematics, you read it like the same way you do a textbook. You read from left to right. Whatever you get to first, you do that first, according to the order of operations. You follow this basic rule, you'll never go wrong. All right, the next thing we're going to talk about. The properties of math. This tells you what to do, when to do, and why you're doing it. Okay, and you don't have to copy this down because when I finish class today, I'm going to scan these and send it to you as a PDF file. So only take notes of the stuff that you have questions with, or just as we're doing problems. So you don't have to copy word for word. I'm going to send you a copy of this audio thingy as well as these notes. I'm going to try to make life easy for y'all. So the first property, the commutative property of to commute. What does to commute mean? To travel? Yes. More so, basically, it means to move. Yes, it means exactly because you commuted from home to here. Whenever you see a colon at the end, that means there's a list. There are two possibilities here of addition and of multiplication. There's two commutative properties. What the commutative property of addition says that if I have any two numbers and I add them together, x plus y is the same thing as y plus x. I can move them around. 3 plus 4 is the same thing as 4 plus 3. They both equal 7. Same thing with multiplication. I could swap them around. 3 times 4 is the same thing as 4 times 3. They both equal 12. So it doesn't matter which arrangement you put it, it's going to give you the same answer. So that's the first property. The second property. The associative property of what does to associate mean? What's that? To put together. So you're forming a group. This one deals with grouping. Again, we have two possibilities of addition and multiplication. X plus y plus z is equal to x plus y plus z. True? But here's the problem. Nothing in our known universe can process more than 2 bits of information at any one time. Computers have to they can only do 2 processes at one time. One number plus another number, one number minus another number. You can't do multiples at one time. It's impossible. So with that, this is where the introduction, remember in order of operations, you do what's inside parentheses first. That's where it's introduced. The associative property tells you which ones to associate together first. So 3 plus 4 plus 5 is equal to 3 plus 4 plus 5. Three plus 4 is 7. 7 plus 5 is 12. 4 plus 5 is 9. So 3 plus 9 is also 12. So the same property goes with multiplication. X times Y times Z is the same thing as X times Y times Z. Three times 4 times 5 is the same thing as 3 times 4 times 5. Go ahead and work this one out and tell me which side's easier to do. Actually, no, you'll see one of them's easier because it's less work. Very good. Yes, the one on the right. Oh, I'm sorry, nobody's finished. Good guess. Yeah, so 3 times 4 is 12. 4 times 5 is 20. The number on the right-hand side is just 3 times 2 is 6. Put a 0 behind it. But the one on the left, 5 times 2 is 10. Carry the 1. 5 times 1 is 1 plus 1 is 6. So the left side requires more steps. So with the associative property and the commutative property, we can move them around to make it easier for us as possible. If something looks difficult to begin with, then just rearrange it following these rules. The third property is the most important one, I think. It's called the distributive property. You notice this one does not have the word of after it. This one's important because it combines both the multiplication and the addition at one time. So it takes care of two things with one swipe of the brush. A times X plus Y. So what it says is, what's this number out in front called? The number in front of parentheses is called a what? It starts with a C. Coefficient, very good. Whatever's in front of a parenthesis or in front of another number or a letter is called a coefficient. What we have to do is multiply this coefficient to every term inside the parenthesis. So it's A times X is AX. Positive plus times positive is a positive. A times Y is AY. So the purpose of the distributive property is to help us get rid of parentheses so we can solve equations. For example, if we had this, 3 times 2 plus x, since we can't do order of operation says do inside the parentheses, we can't do anything inside the parentheses, so we have to get rid of the parentheses by distributivity. 3 times 2 is 6, plus 3 times x, 3x. So we got rid of the parentheses, and now we can simplify the equation further if possible. So that's the whole purpose of it. Now, I told you it's powerful. How many of you ever took chemistry? Stoichiatric equation, stoichiometry, when there's 2 arrows. If you go from left to right, that's distributivity. But if you go from right to left, that's called factoring. What do AX plus AY, what do they have in common? A. So we take out the A, that's our coefficient. Whatever's left goes inside the parenthesis. So if we had this equation, 2x plus xy, what do they both have in common? So take out the x, whatever's left goes inside the parentheses. What do we have left? Yeah. So that's the power of this distributive property. It introduces factoring and it separates the equations for us. The inverse property of addition. So what plus x will give you 0? No. 3 plus what equals 3? 0. But I'm looking at now 3 plus what gives me 0? -3. Yes, that's going there. So it should be the inverse of x is -x. It's the same number, just different sign. That's the inverse with addition subtraction. For multiplication, what times x gives me 1? 3 times what gives me 1? What's that? Nope. -3 times 3 is -9. So how do we cancel 3? What do we need? Not 0, not -3. Because this number is 3 over 1. The way you get rid of the 3, since you're multiplying, is it has to be the same on the bottom. So the inverse of x times the multiplication inverse is 1 over x. More so, if I have x times y, the inverse of x times y, x over y is what? Y over x. It's the reciprocal. It's the flip. Now, both of these we use whenever we solve for x. Look at this one. 3x plus 2 equals 5. Let's solve for x. What do you have to get rid of first? The 2. We get the x by itself to get rid of the 2. Since it's a plus equation, it's an addition equation, we have to do the opposite. What's the opposite of 2? -2. So we subtract 2 from both sides. 5 minus 2 is 3. Okay, that takes care of the addition. Now we have a 3 times x. We have a multiplication. How do we get rid of the 3 in front of the x? Divide by 3. We have to put it on the bottom now. So the 3's cancel. 3 divided by 3 is 1. So that's how the rules of how we move things around to solve for x. Let's talk about signs. Talk about signs for addition. Basically, it's this. If the signs are the same, then take the common sign and add the numbers. If the signs are the same, take the common sign and add the numbers. All right, so for example, 2 plus 5 equals what? Why is it positive? Why is it positive 7? Because they're both positive. So they're both positive. The answer is positive. Likewise, 5 plus 2. Also, they're both positive. So the answer is positive. -2 minus 5. They're both negative. I take the negative sign and add the numbers. 2 plus 5 is 7. -5 minus 2. They're both negative. Add the numbers. So that's basically the rules for whenever you add numbers with signs. Subtraction. If the signs are different, then take the sign of the larger number and subtract the smaller number from the larger number. So if the signs are different, take the sign of the larger number and subtract the smaller from the larger. Five minus 3. Hi, there it is. So 5 minus 3. What's numbers bigger, 5 or 3? So the answer is going to be what sign? Positive. So 5 minus 3 is 2. 3 minus 5. What number is bigger? What's the sign of 5? So the answer is going to be negative. Now we take 5 minus 3. So the answer is going to be negative 2. Negative 4 plus 6. The answer is going to be, so always treat the signs, do those first. Worry about the signs first before you write the numbers. Separate the two processes so you don't get them mixed up. So what number is bigger? So the answer is going to be positive. And then we take 6 minus 4. The answer is going to be positive 2. Negative 8 plus 3. Answer is going to be negative. Then take 8 minus 3 is negative 5. So far, so good. Because this is where a lot of mistakes occur. Right here is with signs. We all know how to add and subtract numbers now and multiply. But what about fractions? Three fifths plus 1/2. Now, yes. I know what you're going to say. When I ask you, what are the rules for adding fractions? You need to have a common denominator, blah, 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 right? A lot of extra work, because if you get a common denominator, then you also have to change the top numbers accordingly. That's why I like the butterflies. I like butterflies. Put diagonal circles over the middle sign and multiply the numbers. So 5 times 1 is 5. 2 times 3 is 6. And whatever sign is there, that goes between the two numbers. On the bottom, just multiply them. 5 times 2 is 10. And there you have it. Does that make adding fractions easier? Let's try different signs. Do it the same way here. Negative 4 over 5 plus 3 over 7. Negative 4 times 7. Is it positive or negative? Negative. 4 times 7. 28. And then 5 times 3. 15. So we have negative 28 plus 15 on top. What do we have on the bottom? Yeah, 5 times 7 is 35. Is the answer going to be positive or negative? Why? Because 28 is bigger than 15. So the answer should be negative. 28 minus 15 is 13. There you go. Now are adding fractions and stuff easier? Okay, how about this? We have a broken butterfly. Yes. Why do we put 4/1? Every number is a fraction. Every number, if it doesn't have a bottom number, it has a 1 on the bottom. So every number is a rational number. Very good. So we just go from there. There. So 4 times 3 is 12. 1 times 2 is 2. 12 minus 2. On the bottom, 1 times 3. And then later on, we'll talk about converting that to a mixed number. But if you get this far, I'm happy. So that's adding and subtracting fractions. How are you with multiplying fractions? I don't know. We're going to talk about that. But yeah, that's what you were taught. But not, yes. No. Actually, that's a good try. Why would we not use find the common denominator here? Oh, because they're multiplied. The common denominator is only for addition and subtraction. I'm glad you said that. Get a common denominator is only for adding and subtracting fractions. But again, when we add and subtractions, we don't need them because this does it for us. No, the rule about fractions, multiplying fractions. This is Arthur's rule. Your first thing you should do always is reduce. Anything on top can cancel with anything on the bottom. Once you finish reducing, multiply numerator times numerator, denominator times denominator, and that's your final answer. It's already simplified. You don't have to go any further. Because I know what you all were taught was multiply all the top numbers together, multiply all the bottom numbers, and then simplify. That's going to be a huge number. But let's try it my way. Let's reduce first. Anything on top can cancel with anything on the bottom, or vice versa. So can the 5 cancel with anybody? Yeah, so 5 goes into 5 once. How many times does 5 go into 25? How about the 3? Okay, so 3 goes into 3 once. 3 goes into 15 5 times. Anything else cancel? Okay, 7 goes into 7 once. 7 goes into 14 2 times. Can anything else cancel? How about this 5 and this 5? That 5 goes into once, and it goes into this 5 once. Is there anything else? That's on the same size. Let's break it down. So what is 6 made up of? 2 times 3, right? What's 21 made up of? 3 times 7. Now it doesn't make it any easier. Do we have any numbers that can cancel top and bottom? The 3 and the 3. So let's see what we have now. 1 times 1 times 2 times 2 times 1 is what? 1 times 1 times 1 times 1. Oh, no, there's a 7. Times 7 is 7. So there's your final answer. Doesn't that way seem a lot easier? So whenever you have a series of fractions, well, let's say we had 2 times 6 over 21. So we have 12 over 21. They're not simplified enough because they both have a 3 in common. But by doing this, breaking everything down to its smallest pieces, you don't have to do anything else afterwards. Make it smaller, cancel anything that looks the same. And then when you're finished, just multiply it. Whatever the answer is the answer. Let's try another one. This time with signs. I don't know what's wrong with this. Is that any better? Let me see if getting closer is any better. There. There. This is a print of the negative. That's of the negative. Go ahead and work this one out. Yeah, I'll send you all the stuff as soon as class, as soon as I get it downloaded. I'll send you all the stuff. Are there anything simple that automatically will get rid of? The what? Yeah, we can get rid of the zeros because they're all multiples of 10. Very good. And what else? Anything look the same top and bottom? Yeah, the 15 and the 15. What's the sign going to be? Is it going to be positive or negative? Yeah, because we have two negatives. If you have an even number of negatives equals a positive because they cancel each out. Odd number of negatives means the answer is going to be negative. So we have 1, 2, so the answer is going to be positive. We got rid of that. That's the whole equation. Yeah. Anyway, yeah, count them all. Yes, that's a very good point. You said you're not supposed to, but sometimes you will have negatives on the bottom. Just count all of them, and if it's an even number, they all cancel each other out. Good question. Very good. What else cancels out? There's a 2. Okay, the 2 goes into 2 once. 2 goes into 6. How about anything else? Okay, 3 goes into 3 once. 3 goes into 12 4 times. You could have also canceled it with this 3 over here. So, which ones? Oh, yes, I forgot. This 3 and that 3. Very good. Good catch. So what do we have left? So 2 times 4 is, and then 5 times 1 times 5 is, and we can't cancel any further, so we're done. Okay, that's a lot easier doing it that way. So you see now when I told you, you don't need calculators to do all this work for you. Because if you did this by calculator, what would your answer look like? 0.043 or something like that. It give you a decimal. But this is the same format as the question, which is typically what you want, is the answer look like the question. So calculators only give you the answers in decimals. Okay. So let's look at chapter 1, section 1. Graphs. It's easier than you think. All right, here's how we begin this. In the beginning, we started off in elementary school with this. What is that called? What kind of line? Number line. We started off with a number line, where you start off at the beginning, which is at 0. Anything to the right is positive. Anything to the left is negative. And we were happy. And then eventually, like, think of how humans traveled. We walked, we swam, we rode horses, buggies, cars, and then all of a sudden we invented airplanes and submarines. Now we can go up and down. Anything going up is positive. Anything going down is negative. We call the horizontal axis the x-axis, and the vertical axis, we call it the y-axis. Anybody know what this is called? Don't say graph. Here are your clues. Nope. It is system. When you have a point, a dot here, what is that called? Another name for that dot? Coordinate, yes. And the top line is the person's name. Cartesian coordinate system. You would never guess how this thing was invented. Thanks to a spider and somebody being sick. René Descartes is a philosopher, mathematician in the 1800s in France. He was lying in bed and his ceiling was similar to this. And he saw a spider walking around. He says, wow, I can tell you exactly where that spider is by counting how many lines that way and how many lines that way. With that, René Descartes discovered and developed the Cartesian coordinate system, or X and Y graphs. Now, at any point we have, yes, it's a coordinate. It's a point. It's also called an ordered pair. It looks like this always. X comes before Y, so X is the first one. Horizontal before vertical. So what's going to be that location? The coordinate of that dot. 1, 1. How about this one? -3, -2, because we go on the horizontal axis first and then vertical. This one. This one. -2, +1, because it goes up. And then lastly, this one. +2, -3. So by looking at the way these points are written, you can tell me where they're located. Whether it's this one, this one, this one, this one. They have names. These are called quadrants. They're called quadrants. This is the first quadrant. This is the second quadrant, third quadrant, and fourth quadrant. In the first quadrant, both signs are positive. In the second quadrant, negative, positive. Because all of these points start from the origin, which is this middle point right here. It's called the origin. Its location is at 0, 0. Everything starts at 0, 0. So you go left 2, up 1, left 3, down 2, right 2, down 3. In the third quadrant, they're both negatives and positive, negative. So if you think about that, the first sign is horizontal movement. The second sign is a vertical movement. So -2, 1, +1. So it's left, up. So it's in quadrant 2. Quadrants are always written in Roman numerals. 2, -3. So +2, -3. You're in quadrant 4, yeah. Both positive, right up is quadrant 1. And both negative, quadrant 3. So far, so good? The question I have of you, why is it numbered this way? Why are the quadrants numbered this way? Oh, no, not numerals, but counterclockwise. Isn't everything we do nowadays clockwise? Whenever we arrange things, we put it in clockwise order. This is backwards. Or is it? How do they keep time in the 1700s, 1800s? They didn't have clocks like we do. What's that? Exactly. So where does the sun start? In which way? The east. The sun always begins in the east. It rises in the east and goes to the, so it goes like this. Start with 1, go to 2, and it continues with the moon. 3 and 4. And then it begins 1, 2, 3, and 4. 1, 2, 3, and 4. So that's the reason it's all labeled what we call backwards, counterclockwise. So far, so good. Now we have a graph. We have a chart. If we have two, I'm sorry. If we have 2 dots on a graph, on a chart, what can we find with those 2 dots? What can we define? With 2 dots. Okay, you say we'll find a line. Yes, we can draw a line, but we can't find a line just yet. We can draw a line through those 2 dots. But what can we find? We can find the distance between those 2. Distance between the 2 points. We could find the halfway point between those 2 points. We could find the slope of the line between the 2 points. And more importantly, we can find the equation of the line that connects those 2 points. Just think all that stuff from 2 points. So we're going to begin first by talking about the slope. Let's say I gave you 2 points, 1, 1 and 5, 4. So I label my graph and plot the points. So I plot 1, 1. So starting from the origin, go over, up. There's my first dot. That's point number 1. My point 2 is I go over 5 units and then up 4. That's point 2. We can connect those 2 dots with a line. So let's figure out the slope. How would you define a slope? You only create angle if you had a slope of a line with a transversal. So it doesn't really have an angle just yet. But yeah, I see where you're getting. But a slope in basic terms is the rise over the run. Let's talk about those. So you have the rise over the run. The rise, if it's positive. If it's negative, it's a sink. It goes down. The run always goes to the right. So we have a vertical change over a horizontal change. A change means difference. So it's a vertical difference and a horizontal difference. So the difference, how far is it between 1 and 7? How far is it from 8 to 15? 7. How about from 13 to 87? What is it? 74. Very good. How'd you get those? What's that? Very good. So we did, to get 6, we did 7 minus 1. To get 7, we did 15 minus 8. 87 minus 13. So this is my first point, and this is my second. There's my first number, x sub 1. There's my second, x sub 2. So how would I find the difference between those two numbers? Yep, x2 minus x1. There's the difference. So if I had y1 and y2, the difference between there would be y2 minus y1. Remember, x is the horizontal, y is the vertical. So vertical difference is y2 minus y1 over x2 minus x1. All this defines the slope. And to make it easier for us, we use the letter m as the slope. So there's your formula. All right, of our 2 points, we have 1, 1, 5, 4. What do x1, x2, y1, y2, what do they refer to? Yeah, since this is the first point, point 1, this is the x value of point 1. This is the y value of point 1. This is the second point. So this is the x value of the second point and the y value of the second point. So notice, to solve our equation, the first thing we should do is write down what we have. What is x1? 1. x1 is 1. What is x2? That's 5. y1 is 1 and y2, 4. Once you define these, the hard part's over. The most errors occur when students transfer these numbers into these variables. So take it very slowly, label them. Now just plug and play. y2 minus y1. So we have 4 minus 1, x2 minus x1. Minus 1. So that's your slope. That's your slope. 3 over 4. Don't make it into decimals, because this means a lot to me. Let's see what this means. So coming back up here to our graph, if we drew a horizontal line through there and a vertical line through there, we know this is 4 units. And this is 3 units. It goes up and down 3 units up over 4. So the slope of this line, so it's from this point, from point A to point B, what do? I go up 3, 1, 2, 3, and over 4, 1, 2, 3, 4. That's why you always want to leave the slope as a fraction. So the next point would be up 3, 1, 2, 3, and over 4. When we drew this triangle here, what can we do now when we have a triangle? Do we know any formulas for triangles? What is that name? Starts with a P. Pythagorean theorem. The Pythagorean theorem. It says a squared plus b squared equals c squared. A is here, B is here, and C is here. So basically, this is the same picture we have. For ours, we know A is 4, B is 3. So what does C equal? 4 squared plus 3 squared equals C squared. 4 squared is 4 times 4 is 16. Yes. 3 squared is 3 times 3. 16 plus 9. 25. 25 equals C squared. We have to get rid of the square. How do we do that? Square root both sides, right? So C is equal to the square root of 25 is? C is the hypotenuse. Another name for that is the distance. The hypotenuse represents the distance between two endpoints of a right triangle. So instead of C, we could say it's the distance. The distance equals A is the horizontal, that's the X values. This is the Y values. So X squared plus Y squared. This one was X2 minus X1. X2 minus X1 squared. The vertical one was Y2 minus Y1. To get rid of the square, we square root both sides. So the distance formula is X2 minus X1 squared plus Y2 minus Y1 squared. There's the distance formula. There's not much work to be done here because if you find the slope, you found the numbers of this. Where do we see these guys before? Yeah. You have the bottom number here and the top number here. All right. So here you have 2 points. I'm gonna give you 2 points. -3, -2, 5, and 7. Find me these 2 pieces of information. The slope and the distance between the 2 points.